applications of anti-differentiation. All right. The main idea is look at the initial condition. All right. The initial condition problems. So by the end of the lesson, you need to be able to apply anti-differentiation to solve some conceptual and contextual problem. So there's initial value problems in some examples. The context is the profit, cost, and revenue functions and measurements. So there will be some initial conditions that you have to satisfy when you do your integration. So the initial value problems. So if we have an expression for the rate of change of two variables, for example dy dx, which needs to be anti-differentiated, and we know what y is equal to when x equals to 0, this is called the initial problem. So we do know what y is when x equals to 0. And for example, in the contextual situation where t is time, dA dt equals 3x squared plus 8, where a0 equals to 50. So therefore, a0 is 50. It says that a is initially 50, the initial condition. All right? So, when x equals to 0, what actually is y? If you draw the function, what is y? Y-intercept, thank you. So if you draw the function, this is the y-intercept. All right? So the value of x equals to 0 of y when x equals to 0 is a y-intercept. So therefore this is called the initial condition. I'm going to go straight to do some examples. Alright? So what I haven't done is actually printed this for you, but I just want you to read it carefully. Just look at example 1. You'll get this question when I upload this on Google Classroom. Alright? So example 1 is a measurement question. A balloon is inflating such that the rate of change of the surface area. So you know the rate of change is of surface area with respect to time. So you know that it's ds dt, surface area and time. So ds dt is given by the differential equation. ds dt equals to 220 plus 5t centimeters squares per second. Alright, so that is the equation, the change of the rate of change of surface area with respect to time. So if the initial surface area of the balloon, initial, this is when t equals to 0, before inflation begins is 18 centimeters square, you need to determine an expression for the surface area for the balloon after t seconds. And then determine the surface area after 10 seconds of inflation. So let's start thinking about how to do it. So A is actually finding an antiderivative of ds dt, correct? You want the expression of the surface area. You just want the S. You know S is ds dt, but you need to work out S. So since ds dt equals to 20 plus 5t, therefore S equals to 20t plus 5t squared over 2 plus c. Now you need to know what c is. Alright? So given that when t equals to 0, S equals to 18. So therefore S equals to 20t plus 5t squared over 2 plus 18. So you know the initial condition, so you can work out what S is, the expression for S. So therefore after 10 seconds, part B, S equals to 20 times 10 plus 5 times 100 over 2 plus 18, which is 200 plus 250 plus 18, which is 468 centimeters square. Alright? Pretty straightforward. Nothing to, I don't think there'll be some really fancy question in the exam. Straightforward straightforward examples, because next year you'll be doing a lot of integration. Alright? All right, example 2. Given that the total raised from the sale of X units of a particular product is Rx, where Rx is such that dr dx equals to 50 minus X over $20 per unit. All right, now, initial problem. Given that the sale of X0 units results in 0 revenue, so when X equals to 0, R equals to 0, correct? So you should be able to determine Rx in terms of R. So A dr dx equals to 50 minus X over 20. So therefore Rx is 50X minus X squared over 40. Yeah? Plus C. Now you know that C equals to 0 when X equals to 0, R equals to 0. Therefore, C equals to 0. The function of X equals to 50X minus X squared over 40. Alright. So when X equals to 100, so R 100 equals to 50 times 100 minus 100. 100 square is 10,000 over 40. So therefore 5,000 minus 250, which is 4750. Alright, so the total revenue is 4750. Like I say, this sort of question, initial problem question, is pretty straightforward. And I promise you it was a short lesson. Oh, actually no. You need to know how to use class pad to anti-differentiate as well. Can you actually grab your class pad? I forgot that I'm going to show you this. You really need to know how to use your class pad. Alright? If you haven't got one, come and grab one from me, please. Grab your class pad, please. Now we are going to do 3x squared minus 6x. Integrate 3x squared minus 6x first. Alright? Two ways of doing it. You can use interactive and calculation, and you know you've got integration, which is this elongated S. Alright, let me go to my class pad. Oops. Alright, let's do my class pad first. Alright, if you look at class pad, go to main. Again, what I would do is edit, clear everything. Clear all. And edit, clear all variables. The previous class tried to do differentiation without clearing the variables, and the answer wasn't correct. Please make sure that you clear your variables. So what you want to do is to type in 3x squared minus 3x, minus 6x. 3x squared minus 6x. Alright? Now, class pad shows you 3 times x squared minus 6x. What you need to do is highlight that, copy that, and bring it down to the next line. Alright? Highlight it. Go execute. You got 3x squared minus 6x. Highlight it, bring it down to the next line. Go to execute. Go to interactive. Under calculation, interactive calculation, the elongated S, the integral sign. And then you will come up with this box here. At this stage, you are working on indefinite integral. You are not looking at definite integral. Alright? Just indefinite integral for this year. And then you are integrating it with respect to x. That okay. This is what you will get. So it's therefore x cubed minus 3x squared. Now, class pad will not give you plus c. You need to include your plus c. Alright? class pad doesn't give you your plus C, you need to include your plus C. Alright, happy with that? Now let's have a look at the slide. So, in my slide, I want to keep that. I see that you can see this is what happened, this is what I physically show you. Alright, using my class pad. Yep. Now the next one, you can use class pad and it's in Math 2. Alright, Math 2 and it's this little symbol here. What I would like all of you to do is try something. Try doing the same thing, 3x squared minus 6x.
No, I'm not sure.
Oops, what am I doing? I want to go up to my class pad. Alright, so go to keyboard, Math 2, and that. So you just need to put in 3x squared minus 6x. I would actually put a bracket in. And then dx. And hit execute. You get the same thing. Alright? So this is what you do with your class pad. If you did not type in dx, it will automatically default into dx. Alright? This is what class pad does. You can try that if you are not if you don't believe me. If I get rid of x, it will automatically do that. Now, just in case you type in the wrong thing, if you type in dy, oops, y, it will give you something funny, which is y times whatever. So make sure that you know you are using, if you are integrating with respect to x, always put in dx. Alright? So I'm going to stop here. You should have some exercises in Saddler for all of you to do.